Learn Git version control using interactive database scenario. Scenario 1. Committing file. In this scenario, you will learn how to initialize a new Git repository and commit file into version control. Step 1. Git init. As this is a new project, a new repository needs to be created. Use the git init command to create a repository. You can see the result. Continue. Step 2. Git status. You can view which file have changes in your working directory and what's been previously committed to the repository using the command git status. You try? Yes, you can see the result. Step 3. Git add. Use the command git add to add LOL.js to the staging area. To complete this step, you need to execute the following code. Git add hello world.js. Yes, you can see. The git status command allows you to view the state of both the working directory and staging area at any point, any time. Yes, just continue. Step 4. Git commit. To complete this step, you need to execute the following code. You can see the result. Step 5. Git ignore. To complete this step, you need to execute the following codes. Let's try. Yes. Git add. Git ignore. Okay. You can see the summary. Thank you. Scenario 2. Committing changes. Start the scenario. Step 1. Git status. As discussed in the previous scenario, Git status allows us to view the changes in the working directory and staging area compared to the repository. You can see that here. Just continue. Step 2. Git diff. The command git diff enables you to compare changes in the working directory against a previously committed version. By default, the command compares the working directory and the head commit. Right? Yes. Continue. Step 3. Git add. To proceed, first stage you change using git add. Committed.js. Continue. Step 4. Stage difference. Once the changes are in the staging area, they will not show in the output from git diff. By default, git diff will only compare the working directory and not the staging area. To compare the changes in the staging area against the previous commit, you provide the stage parameter git diff stage. This enables you to ensure that you have correctly staged all your changes. Let's continue. Step 5. Git log. The command git log allows you to view the history of the repository and commit log. You can see the result. The format of the log output is very flexible. For example, to output a commit on a single line, The command is use this command. Yes, you can see the result. Step 6 git show. While git log tells you the commit, author and message to view the changes made in the commit, you need to use the command git show. Okay, you can see the summary. Thank you. Scenario 3. Working remotely. In this scenario, you will learn how you can share the changes in your repository with other people and combine that changes into your repository. This environment has been configured with a Git repository with a single commit. A remote repository is configured but has not been linked to the local repository. The scenario. Step 1. Git remote. This environment has a remote repository location of \s \remote project \l using git remote at this remote location with the same audition. Continue. Step 2. Git push. Git push command is followed by two parameters. The first parameter is the friendly name of the remote repository we defined in the first step. The second parameter is the name of the branch. By default, all Git repositories have a master branch where the code is worked on. Yes. Through git push or git master command, you can see it. Step 3. Git pull. Pull the changes from the remote into your master branch. Git pull origin master. This command you can see the result. Yes. Continue. Step 4. Git log. As described in the previous scenario, you can use the git log. You can see the result. Command to see the history of the repository. The git show command will allow you to view the changes made in each commit. In this example, the output from git log shows a new commit by different user at johnscrapbook.com with the message fix for bug 1234. The output of git show highlight the new line added to the file in green. Use the command git log grep to find all the container containing as 1234. You can see the result. Just continue. Step 5. Git fetch. Using git fetch is a great way to review the changes without affecting your current branch. The naming format of branches is flexible enough that you can have multiple remotes and branches with the same name and easily switch between them. You can view a list of all the remote branches using the command git branch -r. Now we will see the summary. Thank you. Scenario 4. Undoing changes. In this scenario, the environment has been created with a git repository with a number of simple commits. Start the scenario. Step 1. Git checkout. Use git checkout to clear any changes in the working directory. Okay. Let's continue. Step 2. Git reset. If you are in the middle of a commit and have added files to the staging area but then change your mind, then you will need to use the git reset command. Just try it out. Git reset head. We will try this. Yes. Continue. Step 3. Git reset hard. Remove the changes from both the staging area and working directory using git reset. To complete this step, you need to execute the following code. Continue. Step 4. Git revert. If you have already committed files but realized you made a mistake, then the command git revert allows you to undo the commits. To complete this step, you need to execute the following code. Okay. Continue. Step 5. Git revert. To revert multiple commits at once, use the character to mean minus. Use the command git revert head to head to revert the commit between head and head 2. You can use the command git log online for a quick overview commit history. Escape on commit view. Revert git log online. Escape queue. Escape queue. Yes. Now try it out. You can use the command git log online for a quick overview for the commit history. And to complete this step, you need to execute the following code. Okay. Now we will see the summary. Thank you. Scenario 5. Fixing merge conflicts. In this scenario, you will learn how you can share the changes in your repository with other people and combine their changes in your own repository. Step 1. Git merge. The git fetch command downloads changes into a separate branch which can be checked out and merged. During a merge, git will attempt to automatically combine the commits. The command git pull is a combination of fetch and merge. Okay, let's continue. Step 2. Weaving conflict. When a conflict occurs, the changes from both the local and remote will appear in the same file in the Unix diff format. This is the same format used by git diff. Just continue. Step 3. Resolving conflict. The simplest way to fix a conflict is to pick either the local or remote version using git checkout their staging text command. And use git add staging and git commit no edit command. Yes, just continue. Step 4. None fast forward. Pull the changes from the remote repository and use the default commit message using the command below. You can view the commit with following command. Continue. Step 5. Git rebase. The merge commit message can be useful to indicate synchronization points, but they can also produce a lot of noise. For example, if you are working against local branches and haven't pushed, then this additional information is meaningless and confusing to other developers looking at the repository. To solve this, you can use git rebase instead of git merge. A rebase will unwind the changes you have made and reply the changes in the branch. Apply new changes as if they happened all on the same branch. The result is a clean history and graph of the nodes. Just continue. Step 6. Rebasing pull request. This approach also applies when working with remote branches and can be applied when issuing a pull request using git pull rebase. This will act as if you had done a pull request before each of your commits. Thank you. Scenario 6. Experiments using branches. In this scenario, you will learn how you can create branches in your repository. A branch allows you to work in effectively a brand new working directory. The result is that a single Git repository can have multiple different versions of the code base, each of which can be swapped between without changing directories. Start scenario. Step 1. Git branch. Creates are created based on another branch, generally master. Command git branch new branch name, starting branch takes an exist branch and creates a separate branch to work in. At this point, both branches are identical. To switch to branch, you use the git checkout new branch name. Yes. To complete this step, you need to execute the following code. First, yes. Second, yes. Just continue. Step 2. To list all the branches, use the command git branch. List all the branches with their last commit message using git branch -va. Continue. Step 3. Merge to master. A commit has been made to the new branch. To merge this into master, you would first need to check out the target branch. Merge the commit in your new branch back into master. Use this command to complete this stage. Git checkout master and git merge new branch. Just continue. Step 4. Push branches. As we have discussed in previous courses, if you want to push a branch to a remote, then use the command git push remote name branch name. Continue. Step 5. Clean up branches. Cleaning up branches is important to remove the amount of noise and confusion. To delete branch, you need to provide the argument -d. For example, with branch -d branch name. Thank you. Scenario 7. Finding bugs. In this scenario, we will explore the different ways you can find which commit introduced the problem. The environment has been initialized with a git repository containing a single HTML file which renders a list of items. Start scenario. Git diff 2 commits. The git Diff command is the simplest to compare what's changed between commits. It will output the differences between the two commits. Git log. To see the overview of the commits in a short view, use the command git log online. To output the commit information with the differences of what changes you need to include, type -p prompt such as like yes. This will output the entire history. You can filter it with the number of different options. Use the command git log --grep equal initial command. Git bisect. The git bisect command allows you to do a binary search of the repository looking for which commit introduced the problem and the regression. In this step, we'll find the commit which forgot HTML tags in list. To enter into bisect mode, you use the command git bisect start. Once in bisect mode, you define your correct checkout as bad using git bisect bad. We will define where a bad commit happened. We now need to define when the last known good commit was using git bisect good head file. Step 3 will check out the commit in between bad and good commits. You can then check the commit, run tests. Easy to see if the bug exists. In this example, you can check the content using cat-list.html. This commit looks good as everything has correct HTML tags. We tell Git we are happy using git bisect good. As we did before, we need to check to see if the commit is good or bad. Use cat-list.html. This commit has missing HTML tag using bit bisect bad. We'll end the search and output the related committed icon. Git blame. Which have a blame culture isn't desirable. It can be useful to know who worked on certain sections of the file to help the improvements in future. This is where running blame on a file will output who last touched each line. Git blame is HTML. If we know the lines which we are concerned with, then we can use the -l parameter to provide a range of lines to output. Thank you. Scenario 8. Being picky with Git. In this scenario, we'll pick certain commits from this branch which we want to end up in master. Step 1. Cherry picking. In this scenario, we have a number of commits in the new branch which has created 2 HTML files. In this scenario, we only care about changes to one of the files, but if we merge the branch, then we merge all 5 commits and the unwanted changes. Let's continue. Step 2. Resolving cherry picking conflict. In the same way the merging can result in conflicts, so can cherry picking. To solve conflicts in the same way as with merging, a branch either manually fixing the files or selecting their or ours via git checkout. If you feel like you have made mistake, you can stop and revert the pick using git cherry pick the board. To complete this step, you need to execute the following codes. Git cherry pick new branch 1, git status, git if, git checkout. Just continue. Step 3. Continuing cherry picking after complete. Complete the cherry pick by first adding the previously complete item and then use the continue option. At this point, the default editor, in this case V, will pop up allowing you to edit the cherry picked commit message to include details of the conflict and how it was resolved. To save and quit, Vim type escape colon colon WQ limit. Yes, thank you. Scenario 9. Rewriting history. This scenario will cover how you can rewrite your Git history using reverse to restructure your commits to ensure they are understandable before you push your change. Start scenario. Amending commit messages. Rewriting the repository's history is done using Git reverse interactive. By putting reverse into interactive mode, you have more control over the changes you want to make. To begin, we need to enter interactive reverse mode using Git reverse interactive root. To begin with, Vim can be a little confusing. To edit text, you need to first type I. It will put into insert mode. We want to edit the commit typo in the first commit message needs a commit ability. So the commit change the word pick to match the command we want to perform. Commit in this case revert. To save, escape WQ and enter. Change in message. Then using Vim editor, the commit message to change commit to commit. After saving and access the Vim, you will see the output of each change the commit. Too slow. Oh. A faster alternative to change the last commit message is using this commit and make the change using Vim. Continue. Squash commits. When we enter interactive reverse, we can specify that we want to modify the previous 8 commits using Git reverse interactive head. In the previous stage, we use revert. Here we want to use squash. We want to squash 8 commits into 1. If we label all the commits as a squash, then we get the error cannot squash without the previous commit as there is a base commit to squash everything into. After saving the commit message, the history will be modified. You can see this using following command. Yes, you can see the result. Reorder commits. Reordering commits can help build a better picture of the logical order that work was completed in. We want to reorder our last commit using head to allows us to modify it. Continue. Split commit. Just like the squares in commits, sometimes it's useful to split changes out of commits in order to keep them focused and make cherry picking or reverting easy. Here we want to split the previous commit, we enter rebase mode using our command. As we want to split an existing commit, we need remove it using execute the following commands. Say, once happy with the state of the repository, we tell it to continue the rebase and update the repository with current. You can see the output and the two new commits using git log online. Yes. Thank you.